All right, so what I want to do today is go over some physical planning when it comes to the network. Remember, Chapter 10 is about the planning and configuring of devices on your network. I love this chapter because it goes back to everything that we sort of covered, and it's sort of a good chapter to go to at the end of the semester. This is a logical topology, what we're going to be working with this week. As you can see, I have instructor network, student network, and I have administration network. I have listed the number of hosts for each of these networks. And what our goal today is to do is we're going to talk about how to physically plan this network, how we're going to lay it out. So this is a logical topology. Obviously, when you talk about the physical topologies, the instructor's computers, student computers, and as well as the administrator computers are not going to be found in one room, right? In fact, it's probably going to make up a classroom building, if you will. So if I go to my other diagram, we don't need to do any updates. Close out of that. Oh, that's a shame. Let's zoom out a little bit. Make it a little bit easier for us to read. There we go. And I think that'll work for what I want to do today. So the question becomes, when we first implement our diagram, when we first set up our network as administrators, we're going to look at it logically. What do I need? And so what I said I needed was I needed a couple of networks. I needed an instructor's network. That's a U. Students, administrators. Can you think of another network I'm going to need? Another logical network? So I have instructors, students, administrators. What else am I going to need? If each of these are their own network or their own subnet, as we're going to discover later, what other network I'm going to need? Yeah, the WANs. Now, I'm going to put WANs, plural, in parentheses. And the reason I'm going to put it in parentheses is because maybe I have a router that has 3 interfaces, one for each of these, and maybe I don't, right? So it might require 2 or more routers. And each connection between a router to a router forms a wide area network, correct? What type of cables do we use to connect routers together typically? Yeah, why do we use serial cables and not Ethernet cables? Yeah, but even though a serial has a clock rate, Ethernet sort of has a clock rate built into it because they have that preamble to set the beat, and so it automatically adjusts the clock rate according to the environment. In fact, that's one of the things we want to discuss is what is the environment going to be like that we're going to be laying these wires. But why a serial cable instead of... compatibility kind of thing? That's one. One of the things we want to experience in the lab settings is typically when you go to set up routers, you're talking about large geographical distances, right? When you have large distances, large spanning distances, you have 3 layers of interference to deal with. You have the resistance in the wire. The longer the run, the greater the resistance, correct? You're also going to have the EMIs, the electromagnetic interference, as well as radio interference or radio frequency interference, RFIs. Okay? And so we prefer serials because, one, we're just beaming zeros and ones in series, hence the word serial connections, and we can adjust the clock rate so they can go further distances at slower rates. 2, that's adaptable. We can use a CSU/DSU, a modem, to connect or bridge these different routers from different areas, okay? But how does that vary over Ethernet? What's the limitations with Ethernet? Especially when we're using copper Ethernet. The distance. See, an Ethernet frame is large. And when you are dealing with data going across larger distances, the longer your frame, the less payload. And what is payload? It's the actual data that you and I care about, correct? So when we come down to it, when we look at Ethernet, we're talking about local delivery. Because the maximum distance is about 328 feet, or 100 meters. Now, that's what we're going to explore today. We're going to take this logical topology, let it meet the physical world, and that's all I want to focus on. Wednesday's class, we're going to come back, revisit this, talk about mapping out IP addresses, assigning different subnet addresses to these networks. But initially, I got to look at this and say, what am I going to do here, and how am I going to connect things together? So this is our building. First thing I'm going to establish is where do I want to centrally locate my intermediary devices. Now listen to the word, centrally locate. When I mean that, I don't refer to like where's the center of the building and that's where we should be putting our equipment rack. I got to think of this as being a multi-layer building. In other words, it's going to have multiple floors. What area in this building might be common throughout all the other floors? Now I haven't included that here just yet because this is a very small simplistic diagram, but typically the area that connects floors together is what the most common area is, like a stairwell, like an elevator shaft. Can you guys think of any other chimneys? Yes. Or how about HVAC locations when you run the ductwork? Okay. So the thing that I'm trying to understand when I go lay this out is, do I have to deal with multiple floors? If so, how am I going to locate my intermediary equipment so that when I do my vertical runs, it's going to be easy to install, maintain, and possibly upgrade or modify in the future? So when I look at this diagram, what area do you think might be shared with the floors above or below? Well, do you think the floors above is going to have a door going to the outside? No. So this structure right up above it, this is probably going to be a lobby to greet our guests that are coming in. Remember, consider this a classroom building. So students are probably going to come in here, but I'm not going to make this a classroom, correct? Probably not going to make it an office. And I'm probably not going to assign my administrators here. Who might get assigned here? Administrative assistants, secretaries, if you will, yep. So then we look at these other structures and we got to say, okay, what would this be? Out of these, which one would make an ideal classroom?
Bottom left.
Bottom left. Why would you say this? It's the biggest room? Yep. So let's make this a classroom. Oops. Which one's going to be for instructors? Yeah, probably these rooms right in here. Let's call this I.O. for instructor's office number 1. And I.O. instructor's office number 2. And so what room would that be? The admin? Yeah, that's on another floor. So we're calling this the lobby. Well, guess what? You just got done eliminating areas to put your intermediary devices, correct? Would it make sense to put routers in any one of these rooms that we just got done labeling? Okay, I got a yes and I got a no. Do we want our routers accessed by the public? We don't even have a router in here for you guys to access, not even in our wiring rack. Why not? How often do we have to see our routers? You do the initial setup. Done, correct? It's connected to the internet. As long as all is working, you should never have to touch that router again unless you make changes. Unless you add other logical networks, correct? So it should be set up and forgotten, assuming all goes well and you're not modifying or adding to. The other thing that we wanted to consider is routers implement security techniques, correct? They also control our bandwidth. And so if I have access, if I can access it from a public lobby, what's to prevent somebody from taking a console cable, plugging it right in the back of the port, booting up their laptop, and reconfiguring things? It's true. Not the hard barb there. So, but what if the administrators aren't around or the secretaries aren't around? How do we govern that? The very first line of defense when it comes to your routers is the physical layer. You need to lock it up. You need to put it in some room. In fact, as I'm building this, I might even suggest we block in that window and we build a wall between here and there, and this becomes my wiring closet. Now, I would assume that this area right here is probably going to be a shared area above. At least that's what I'm hoping. But if I can keep my equipment on one of the floors, by the way, what floor would you recommend putting your wiring closet? Top, middle, or the bottom? Second floor? Why is that? All your wires are going to be being routed to the wiring closet, correct? If you put it down at the bottom, then the runs going up to the second floor are going to be a lot longer. Remember, the maximum distance between between devices is 328 feet. That could be between two switches, between a switch and a router, between a PC and a switch, or a PC and a router, correct? Buildings are typically 10 feet high per floor, give or take. So I'm not too worried about that. What is the other things to consider? If you're going to be putting your wiring closet somewhere, you're probably going to be having servers, switches, routers, modems. Notice I put this on an outside wall. Cooling might be a big factor. The reason why I might have put this on an outside wall is because my internet service provider is going to have to come in. And if I can make that as easy as possible to get to the wiring closet instead of running that even longer distances, it's one factor. I put it on the middle floor because, you know what? If the building burns down and we have a sprinkler system going on, what do you think is going to happen to the basement? It's going to flood. So then one could argue, why not on the second floor then, on the highest point? What's that? Okay, well, heat rises. I guess that could be a problem, but really when it comes down to it, and you'll find out in big corporations, they don't use sprinkling systems. What do they use to put out fires? No, not foam. I don't believe that. I think that's in science fiction movies. That's exactly what they do.
Oh, I was joking. Okay.
No, yeah, they actually, they suck out of the air or they replace the air with some nitrogen.
Wouldn't that kill the employees? Is that what?
No, only in the equipment room they'll do that.
Oh, okay.
Yeah,
Okay.
only in the equipment room they'll do that. Yeah. What about the employees? We don't care about them. No, only in the equipment room. And that's why we're talking about the location of the wiring rack, because, you know, this is probably not a good location. In fact, we might even build it in its own warehouse and create sub-locations that we wire to.
So they have like a vacuum seal on the wiring closet, or like the rooms around the wiring closet?
No, call it a wiring closet, call it the equipment room, wherever, but they're actually airtight and they will suck out the air.
Only fires inside the wiring closet can get put out with.
Exactly, in just case there's electrical fire. And the materials that they use to build around it have like a 10-hour or 12-hour fire resistance, so that if the building is on fire, the fire company can put that out, and then the material should be safe. The other thing that they usually tend to put in this is, well, it's airtight, so it's going to be watertight. So in case the sprinklers from the other parts of the buildings will come in. Yep. So these are all the things that we're factoring in, folks. Now, obviously, part of your job as administrator isn't really to get that technical. It's about the ideal location, but you want to consider things. You want to consider public access. To me, this is a really bad area. I'd probably move the wiring closet up on the second floor, not on the first floor, because the first floor, basically, it's really public access. A lot of people are coming and going. I mean, right here is the lobby. What's to prevent them from just jumping right in there? The other thing you want to do is be misleading. You might want to put signs out there that says warning equipment on only authorized person in there, and make it look like it's make it look like it's a utility closet. So when somebody goes into it thinking, oh, this is where everything's at, this is where I need to go to find it, and then they open it up and they see a bunch of brooms and mops. You know, you want to hide in plain sight. Obviously, when you're building up your wiring closet, though, you're going to see a bunch of wires, and it's going to be obvious that that's what it is, correct? So let's just say, for argument's sake, we're going to put our wiring closet here. I hate that this is a location, but out of all the other locations, it's probably the better one.
What if you built a closet in the administrative?
There you go. There you go. What's to prevent us from actually putting it inside of another room and saying that this becomes the wiring closet? Or even just building it right across and getting rid of the windows. Right? Is it centrally located? It doesn't need to be. It's in a better ideal location. Whether it's on the first, second, or third floor, if it's in a corner possibly, or maybe in the center of the building, as long as it meets some physical requirements, like doors are locked, that there is no windows, that the only way to get through it is through a layer of security. Like maybe this door should have a padlock. So let's just agree that we're going to move the closet right here, and we're going to block in the windows so that they're filled up. Nobody gets to see it from the outside world. And now the administrator's office serves two purposes, correct? Next question. Now we allocated our networks and assigned them a physical space. Would it be a good idea if, and let me go back to my diagram so I can write down the number of hosts. All right, so the administrators, I have 20 hosts. Let's see, what else we have? And you notice the server's part of the administrative network. Students, we have 460. And let's see, instructors, we have 64. Seems right. And the WANs we'll determine later. Just, oops. Knowing this, would it be a good idea to run 460 cables from the classroom to the, what should I probably put in the classroom? I have done this before, and now I reconsidered this whole process. In fact, in this classroom, it's probably poorly laid out. All of the computers go right to that rack, and I'm a little disappointed in doing that. The reason why I'm disappointed in doing all of that is because over on that wall, you can see, if you guys pound on that wall, it's a solid concrete wall, and on the outside of that wall is called a raceway. You'll notice none of the wires are just laying down on the floor so people can trip over, and they're protected by some kind of shield, if you will. And in that raceway, we have a bunch of wires being ran. The furthest wire that we had to run is going to be that back computer. All right? So it's going to go horizontally that way, then up along the wall, then into my rack. What could I have done differently to make it a lot easier, where all I would have had to run was 3 cables, and they wouldn't have been as long? Put a switch after each row. What would I have gained by putting a switch at each row?
Collision domains.
I would have increased the number of collision domains, which would have given me better performance. What else? What's that? Less cable. However, it would cost me more, ironically, because the switches cost more than cable. But it would have saved me in time, correct? But what else would I have gained if I put switches at the end of each of my tables? Not only that, but I can increase the devices on my rows. So if you guys brought your laptops and whatever, I can have like a drop cable and you can plug it right in. Right now, if you guys want to hook up your laptop, I got to run a whole wire from where you're at, up along the wall, into the raceway, into the patch in the patch panel. All of which would be inefficient. So here, maybe it'd be a good idea if I put switches in each one of my rooms. But how are we going to join these switches together? What devices are going to connect these switches together? So if I have to use a medium to connect the switches, but what do I connect the switches to? A router? Interesting. So, no, it might be right, it might be wrong. It all depends on what we're trying to accomplish here. If I had a router here, so is this what you want me to do? I mean, if I'm going to connect the switches together, do I put the router here? And do I connect it this way? And then do I put another router in here? And then do I put another router in here? And then another router in here? And then another router in here? But isn't that what we argued? We said we don't want to make the routers publicly available, correct? And do I want to keep on buying all these routers? I mean, according to this, I have 1, 2, 3, 4, 5 routers that I have to buy. And by the way, routers cost more than switches. So what am I going to do here? how am I going to join these local area networks together so they can still share resources? Yeah, through a WAN, but the question is, you need a router, exactly. What if I do this? Could I put a switch in here and have all my switches plugged into that single switch?
Can you go like a router in with like the two IO 1 and 2 and maybe share a router?
Okay, remember what a router does for us. It allows us to separate networks, correct? So the question is, if I put multiple routers in here, one, it'd be wasteful. Two, look at where they're located at. They're stuck in the employees. Trust me, I don't even have access to the school's routers. In fact, I'd be surprised if the school has multiple routers. I would expect it to only have one router. So if I were to set this up here, hooking up my switches into a switch and only have one router here, what's the problem? And there is a problem with this.
Seems weird to have so many switches connected to another switch, but I don't know if that's what you're going for.
You don't know nothing.
Thanks, man.
Let's go back to our logical topology. We have taken the larger network and we divided it up into subnetworks. And the problem is, in order for subnetworks to communicate with each other, don't they need a gateway? So each of these networks would need a router, correct? Or an interface of a router. We clear about that? What do we assign our interfaces on a router? An IP address that belongs to a particular subnet range, correct? So in this case, it doesn't make sense to put the switch here, but rather have a router with multiple interface cards that allows me to join all of those switches together. That's one way of doing it. There are multiple ways. In fact, the way I would suggest doing this is that these become virtual LANs, VLANs, which is beyond the scope of this class. And then they would then, in fact, hook up to switches. And then that switch would then hook up to a router, and that interface of the router would actually have multiple IP addresses assigned to it. That would be the most effective and most efficient way, both cost and performance. But once again, that's beyond the scope of this class. So what we're going to do is talk about the way we've learned in this class. This router is going to have at least 1, 2, 3, 4, 5 interfaces. Do you see why I put this in quotations? Like, do we really need a wide area network? In order to create a wide area network, we need multiple routers, correct? Here I'm going to go with one router that has a lot of Ethernet interfaces. By default, how many interfaces are on a Cisco router? 2. Ethernet interfaces. 2, correct? But you remember how we had to add serial cards to get the serial interfaces? Why can't we add more Ethernet interfaces by adding an Ethernet card? As long as each interface is assigned an address that belongs to each of our subnets, we shouldn't have a problem. Now you do see a lot of cable being ran. The type of cable that's being ran from the switch to the wiring rack is called a horizontal cable. How many cables do you think I would have ran from this switch to this wiring closet? 1 or 2 or maybe more. We'll make it multiple choice. How many people say 1? How many people say 2 or more? All right. Why are you saying 2 or more? Exactly. What else could you do with the other cable, though, too? I guess the biggest trend, and it's been around for a long time, but hard drives are becoming more and more cheaper. In fact, they're becoming even smaller that when you go shopping for laptops, you can actually get this option installed, which I'm really amazed. Because back in the day, the hard drives for laptops were so big you can only fit one in them. But with SSD drives, you guys can fit multiple hard drives in a single laptop. So if you got 2 hard drives in a laptop, whoop-de-doo, what are you going to do to get better performance out of that? Use them both at once. What do we call that? RAID. Redundant array of inexpensive disks, right? And you can create what we call RAID 0, which is striping, which allows you to take half of a file, split it up into the equal number of hard drives. So if you have 2 hard drives, you cut the file in half. One half would be stored in one hard drive, the other half would be in the other. What do you gain by doing that? One, you increase your storage capacity to twice, correct? But more importantly, your read-write speeds, in theory, should be doubled, because each hard drive is assigned its own interface. That interface has this particular amount of bandwidth, correct? Why can't we do that? Why can't we run multiple strands where we use it for not only redundancy, but load balancing? When you have 460 people or devices accessing a network, you're going to saturate that single pipeline. So how do you make the pipe bigger? Add multiple lines. Here's the other thing. Cable is cheap. If you are tearing down the ceiling or the walls to run this cable because you do not want it to be exposed and you want a professional job, most of the time what people will do is they'll run it in the basement where there is no offices, underneath the floor joints, or in the ceiling, taking down the ceiling tile. Here's a word of advice. When you buy Cat 5, it comes in boxes. It's typically 1,000 feet. Don't buy 1 box. Buy 5 boxes. I'm speaking from experience, okay, guys? So learn from this. Now, you take 5 cables, 1 out of each box, you take some electrical tape, and you bound it up. It is easier to run a bigger cable than it is 1 cable, especially across ceiling tiles. You're pulling it at one time, and you're getting 5 cables. And every so many feet, keep on tying some tape around. You want that bundle to be intact, especially when you're running long distances. Why? Why don't you want it to fray out a little bit in the middle? It's going to get stuck. It's going to be a pain in the ass to troubleshoot later. All right? It's going to wrap around things. It's going to get tangled around itself. So after so many feet, either use a zip tie or black electrical tape, bound them up, and keep it going. Would it be a good idea to terminate all of those bundles? Doesn't matter, really. It all depends on how many ports you have available on your switches.
Now, when I work construction, I don't know if this is common practice, but the dude that was with us, that was the electrician, he was running new cables, and he had like a wad, like this big network cables, and he used soap detergent.
Yes. I'm glad you put that out. Yes. Yep.
Pull it through.
Yeah.
I'd never seen or heard of that done.
Yeah, I do it all the time, especially if you're using conduit.
They said it's like the only good thing to use.
Yep. Yep. So the question was, why are they using soap detergent or some kind of lubricant? If you're using conduit or a raceway and you're running a large amount of cable at one time, what happens is the cable gets, it increases its surface area, right? It acts like one big giant cable. And when you're trying to run that through some kind of drilled hole, conduit, pipe, or whatever the case may be, you're going to get friction. And as you try pulling this cable, especially after 100 feet of it, it gets heavier and heavier, that the cable itself, internally, the copper could expand, and you could pull it apart before you could even pull away the PVC jacket. So what they suggest you doing is you lubricate the outside. So you just run your hands in a bunch of soap, and just as you're pulling it, and you usually have 2 people, one person at the box and the other person at the far end trying to pull the cable as it goes. The person near the box is just putting their hands in soapy water, and they're just running it up and down the cable as they're pulling it. Now, this is the thing I would suggest. When you're doing this, look at your wiring closet, and I would put a 6-inch PVC pipe, even in your house. Do this. If you guys are doing new construction or whatever the case may be, go get Schedule 40 PVC pipe, 6 inches, 4 inches if you have to, but 6 inches is what I'd recommend. Run it from your attic down to your basement. This is going to be the backbone. This is going to allow you to install your vertical cables. Now there's going to be 3 terminologies that we're going to cover: horizontal, vertical, and patch cables. Make sure you understand the difference. Vertical cables are used to connect wiring closets or telecom rooms together. They're also used to connect how can I say? I don't want to say networks together, but buildings together. Is that okay? Because it is possible to have multiple buildings with one network. All right, we have that situation here. We have the classroom building, but then right next is the Learning Resource Center. Correct? So vertical runs don't necessarily have to mean up and down. There typically are because we stack our wiring closets above them. And I strongly recommend that you get a conduit pipe, 6-inch pipe, and you install that. Put it in the wall, put it on the outside of the wall. I don't care because this is your wiring closet. People don't get to see the wiring closet. The reason why you're going to run this pipe up and down the building is that if you ever have to add a new network, divide a room in half, it's going to be so much easier for you to add wires in the future by having that conduit. And by the way, when you run that pipe in there, put a piece of string in there. What is the string going to be used for? When you're in the attic, and why is the attic a really hot place? No pun intended. But why is the attic a really hot place to put cables, especially in a home? Yeah, I didn't mean that as much. Why is it an attractive place to put your cables in the attic? It's easy to drop down. Think about your attic and think about where your bedroom's located with respect to the attic. Your ceiling is right underneath the attic space, correct? So if you want to add an Ethernet jack to your room, it's a matter of just poking a hole to where one of the studs are, and you can see where that is. If your attic is not finished and it's just a classic attic space, you can remove some of the insulation and you should see some of the what do they call them? They're cattails, I think is what we call them in the field. But they're just like 2x6s that are standing upright that go across the floor joists that anchor the walls, your partition walls for your bedrooms. And so when you know where those are, you know where your walls are at. And you guys can drill down through there and not have to interrupt any of the drywall. And you would have a professional installation. Likewise, the basement. Think about the basement. What's above the basement? No. You live in a very small house. In a basement, above is the first floor, right? So if you have that vertical pipe that I'm telling you to connect the wiring closets together, you have access to the first floor rooms, and you also have access to the second floor rooms. And typically, how many floors are in a home? First and second floor. Where would you tend to run that vertical piping? Yeah, where at though? Where would you be able to get through with putting that vertical piping in an existing part of your house? Might work. Where else? Stairway?
Old laundry ducts.
Laundry areas?
Old houses.
Yeah, those dumb waiters. Could you even use an existing pipe? Every one of your homes is flushing. If you guys didn't have this, you'll notice that if you look at roofs, they'll have some kind of venting duct. There might be an open PVC pipe out there. Anybody know what that's for? All right. Think about when you flush a toilet. What gets replaced with the water at the time that's flushing? In order to actually flush a toilet, how does it work? All right, so we understand that gravity's pushing down in that pool of water, correct, in the toilet? When you hit the handle, you open up a valve, and then gravity pushes that water down the pipe, correct? So air is going to be sucked through this, correct? That air has to be supplied. So that vent that you see that's out in that roof is a supply duct for your plumbing, so that when you flush your toilet, the water won't sit there. Now you guys know this to be true if you just take a straw, put it in your soda, and cap the one end with your thumb and pick up the straw. What happens to the liquid? Stays in there, right? And that's what would happen to your toilet if you guys tried flushing it and you didn't have a vent. What's in that vent? Nothing but airways. Could you literally run your cable through your sewage pipes? Yeah, it's a smelly job. I've had to do it once or twice. But it will work. How often are you running vertical cables? Not often at all. It should only be once or twice. Yeah, I was waiting for that one. That's right. It will work. However, if you're going to do this, make sure you properly seal it so that when they do flush the toilet, it doesn't leak out on your cables. Would I recommend doing it? Only if you're in a pinch. Most wireless connections are working a lot better today. You guys can get the bandwidth. The problem about wireless connections is what? They're very prone to radio interference, obviously. The other thing is security. You don't know where exactly the signal's going to. So let's just go back through this diagram, talk about the proper terminology. Keeping it generic. You want to make sure that you have multiple wiring closets, one for each floor. Okay? In those wiring closets, wherever they may be, you're probably going to have a router, a switch, and in one of them there's probably going to be a modem. Some of these devices are thrown all together, which we call an integrated service router, correct? Multiple services running at the same time on the same device. We connect them together using vertical cables. Typically, anytime I'm connecting anything together, I'm going to run at least 2 cables. One as a backup, or to all alleviate or load balance the network. Next thing, from the wiring closet, I'm going to be running what we call horizontal cable. Not because it's typically ran horizontally, but rather because it terminates through a wall jacket, as well as what we call a punch panel, or patch cable, sorry, patch panel. Oh, there we go. Now, most horizontal cable is ran along a wall, but it doesn't have to be kept in that mindset. Okay, guys? I want you guys to understand that horizontal cable doesn't have to be ran horizontally. What we mean is it connects the rooms next to the wiring closet on the same floor. And typically rooms are horizontal. They're on the same horizontal plane. We good about that? Hence the name. Could you have ran this up through the ceiling and then back down to get to the person? Absolutely. Is it called a vertical run? No. It's called a horizontal run because the room is next to the wiring closet. Okay? Once again, when I'm doing a horizontal run, I'm going to run multiple wires. All right? I am going to terminate it with a wall jacket, as well as I'm going to terminate the other end at a punch panel. The wiring rack, as you will see, and in this case I'll show you guys in lab tomorrow, will have a punch panel. I will not terminate this cable with an RJ45 connector. Why will I not terminate the horizontal run with an RJ45 connector? Remember those RJ45 connectors, those 8 little brass pins that you guys used last lab to make your crossover cables? Why would I not terminate this, and why would I buy more equipment? I'm adding to the cost. What's that? Actually, it might impair the performance because every time you have a break in the wire, you're going to increase resistance, hence it's going to affect performance. But it's always a give-take relationship here. Why would I want to buy these little phone jacks, if you will, and terminate every one of my cables with those, every one of my horizontal runs with those, and then on the other end, head into a patch panel, which could cost me a couple $100 extra? Think about the nature of this cable. This cable is probably going to be in a wall, in a ceiling, and how often do you have to deal with it?
Probably never.
If it's done correctly, probably never, after it's installed. How often you guys are replacing electrical wires in your house? Never.
Place burns down.
Until something goes wrong, exactly. That's why we want to treat this. We want to try to treat this as a permanent fixture. In fact, if it's going to be a permanent fixture of your house, you probably want to buy high-end cable. If the standard right now is Cat 6, you probably want to go out and buy Cat 7, correct? So if I'm going to terminate this with the wall jacket, what do I gain by doing that? No different than what do I gain by terminating it with a receptacle in my house. Think about this. Here we have a classic example of electrical outlets. I have a receptacle down here. Do you notice I didn't take the electrical wire that's in there and give it an end that could be used to plug into my PlayStation? I kept it generic, didn't I? That is the universal outlet. Every electrical component device that we have should, if in this country, should be compliant with that receptacle, correct? And what if I can't exactly put, like that's a classic example of bad location for an outlet. Why? Yeah, I shouldn't be running electrical wires across the aisle, correct? So what I'm going to do to attach my device that doesn't have a long enough cable to reach that outlet? Get an extension cord. From our wall jack, we're going to hook up a patch cable. Typically, that's going to be hooked up to a switch. And from the switch, we're going to run other patch cables. What you guys made last week would be an example of a patch cable. Patch cable should be no more than 3 to 5 meters, about 10 to 15 feet. Okay? Which should be about the diameter of a room. If you centrally locate your switch, no device should be more than 15 feet from that switch if your room is within a certain size, correct?
Yes.
How long should your horizontal cables be? Remember, the maximum distance for Ethernet is 100 meters. How long should your horizontal cables be? Close. You can increase it up. What's that? 75? Yeah, 75 to 80 meters. All right. Now, in this patch panel, we're also going to have patch cables. In fact, they're going to be about this small. This is definitely a job that you give to your worst students. Think about this, guys. I had to make a little cable to join my horizontal run that terminated at my patch panel to hook up to my switch. And literally, it's about this size, if not smaller. Look how many ends you had to make. You guys know what that was like last week, right? Could you imagine doing that for 24 ports? Huh? Now somebody asked, what if I didn't do a lab? Okay, well here's your redemption. No. Luckily we got these all made for you. Why would I do a thing like that? Why would I terminate here at this patch panel just to make an extra cable, correct? I mean, as I'm looking through this, I got to make a patch cable to connect my patch panel to my switch. Then I got to make a patch cable to connect my wall jack to my switch, and patch cables to connect my PCs. Those RJ45 connectors are adding up. It took you guys, what, about half an hour last week to make one of these cables?
45 minutes.
Add it up. It adds up pretty fast. Why would I do that, though? Equipment is changing all the time. We are going from 10 megabits per second all the way up to 10 gigabit Ethernet. And you know what hasn't changed since that updates? The type of cable we use. We're still using twisted pair. All that I had to do, when you guys go from 100 megabits per second fast Ethernet to a gigabit Ethernet, what do you need to buy? What do you need to update for your hardware? A new switch, one that supports 1 gig. What else are you going to need to update? A new network interface card, and possibly a new router, correct? I didn't mention anything about the RJ45 connectors, the wall jack, the cable itself, or the patch panel, correct? So if I go to add another piece of equipment in my wiring rack, that piece of equipment is going to be physically separated from the from the patch panel. I don't know what the size is going to be. By doing these jump cables, if you will, it allows me just to make a new little piece instead of ripping my walls out and rerunning the cables. Does that make sense? It's more cost effective in the long haul because those cables in your walls are probably going to stay that way for a very, very long time. But the speeds in which we transfer data, that's probably going to change. So all we have to do is update our intermediary devices and our interface cards, and we're done. What if they decide to say we're going to use a different cable? As with anything in life, if they're going to change something, expect there to be an adapter. Correct? So I modify my intermediary device that's in my room that can handle the new medium. What type of device do we call those? That connects one medium to a different medium? What's that? Well, it makes it compatible. What is the generic name we use for those devices that actually connect? Well, we're not really converting much. It might convert the signal if need be. They're generically called a bridge. Another device that could do the bridging between the two is also a router. So routers and bridges can handle multiple different forms of connections, right? Look at our routers that we've configured. Do we have a serial connector hooked up to a router which also connects to a fast Ethernet? Doesn't the router have to change or communicate between the two different interfaces? So that's one thing to consider. This allows us, by properly planning our physical network, to modify or update our network easily compared to if we just hardwired everything together. So before I let you guys go, what is the benefit by having a wiring closet on each floor? Actually, it might, in our original diagram, the way we laid this out is we had different networks on the same floor. We might be able to organize our corporation so they're one network, one floor. Security might propose it might be split there, because by distributing you're not keeping all your Easter eggs in one basket, right? But second, you increase the number of places that people can access it. So it sort of negates itself, if you will. So what do we gain by putting a wiring closet on every floor? Shorter horizontal runs.
More work for us.
Yeah. And it costs more. But short horizontal runs. The total length, that is the patch panel with the patch cable to your intermediary device, plus the horizontal run, plus the patch cable, has to add up no more than 100 meters. Correct? So that's why we say the patch cable is no more than 10 meters, and we say your horizontal run no more than 80. Because 10 plus 10 plus 80 gives you 100 meters. Are we good with that? That's between any device. Question, how do you wire your horizontal runs? Do you wire it into a straight through configuration or a crossover configuration? Answer to on that would be on Wednesday's class. I want you guys to think about it. What's the one that's most universally accepted? What would make it easier? When do you use a crossover? Only when you're connecting like devices. So we'll get there. We'll talk about that on Wednesday's class. I want you guys to read Chapter 10 stuff. A lot of this stuff is really trivial. In fact, Chapter 10 will go back to looking at VLSMs, and that's logical planning, which is what we'll cover on Wednesday. So horizontal runs, vertical runs, patch cables, make sure you guys know the difference. Maximum distance, 100 meters. And make sure you truly understand and appreciate this concept of modular design, breaking things down. One of the biggest benefits about having a wiring closet is for troubleshooting. If one floor is down and all the other floors are working, you go to that wiring closet, look at the intermediary device. If you're on the same floor, it makes it really easy to communicate with each other what's wrong. And if you have to rerun a cable, all you're doing is from one room to another room. That's it. In a home situation where there's very few devices, it might be overkill. That's why I only have one wiring closet in my home. And it's in the basement, ironically. It's easy for me to get to from underneath everything. You guys take care. I will see you guys on Wednesday, or actually tomorrow.